AMC 12A 2022, problem 18. We want to consider ideas of this problem, and also I leave homeworks related to this problem. So try this problem first on your own. For this problem, the idea is, let me write, consider a small example which is useful in many problems of, I can say in all years of AMC, AMC 10, AMC 12, AMC 8, AME, USAMO, considering small examples, IMO. So here, if we apply T1, let's see what happens. At first, it says let Tk be the transformation of the coordinate plane that first rotates the plane k degrees, so clockwise. So k degrees clockwise rotation, k degrees counterclockwise around the origin, and then reflect. And then reflects, so here we have reflection. The plane across the y-axis. What is the least positive integer n such that performing the sequence of transformations t1, t2, t3 to tn returns the point 1, 0 back to itself. Okay, so here let's apply t1 first together. Okay, at first our point is in what position? 1, 0. Then we rotated 1 degree. Okay, so for example like this. And then we reflect it about y-axis, so it will be this. So we will reach this point. So let me show a better line. Okay. Now we know this length equal this length equal this length. So the length equals 1. Okay, so from origin. If we find the angle, then we can find the point. And it says what? It says find the what is the least positive integer and such that that performing the sequence of transformations t1 to tn returns the point 1, 0 back to itself. So, because if you check in each part, the distance from origin is 1, we should find the first point that the angle is 0, okay? So, for t1 at first, we know the angle is 0, if we consider the angle that it creates with x-axis, okay? Right side of x-axis, it is 0. When we rotate 1 degree counterclockwise, the angle will be 1 degree. Then when we reflect it, it is t1, this operation. This point has what angle? Let's calculate this. We know this angle when we reflect equal to this angle because these two triangles are congruent. Okay, so this angle equals this angle, so this angle equals this angle, so it is 1. We can conclude it is also 1. So this angle will be what then? 180 minus 1, 179. Okay, so after applying T1, we reach these two angles. So now apply T2, T3, T4, T5, T6, and then you can find the pattern of these angles and you can find the first point that you reach 0. Okay, so try this part first on your own. Okay, let's apply T2. At first, plus 2 degree, 2 degrees here, 181. And then we reflect it, okay? For example, it is this one. When you reflect it, it comes here. So here it's 2, so it will be 2. But here negative 2 will be what? Will be 358, okay? So it will be 358 after applying T2. Now let's apply T3. It will be what? Plus 3. So it will be what? I'm sorry, 359. When we cancel 181, it will be negative 1, 359. Okay, then we add here, it was plus 2, here plus 3. 362, which is what? Which is 2. And then it will be what? 178. T3. Then we add 4. It will be 182. Then if we consider this part is 358. It's what? T4. If we reflect. T5. 5 plus this will be 3. If we reflect it, it will be 177. It will be what? T5. T6. We add 6, 183. And if we reflect it, it will be 357. Okay. Now you can find the pattern. We have some types of numbers. Okay, if we consider pink numbers, so you say 1, 2, 3 in the mid part of each TIs. Now let's consider green ones. 179, 178, 177. Red ones, 181, 182, 183, and so on. And black ones, 359, 358, 357. So we have 4 colors for each of them we want to hunt. Maybe the problem here, we have 2 approaches. Maybe the problem means after applying, for example, here it says Tn, after applying Tn completely. But we will also consider the mid numbers, okay? And we will see the answer is between these 2 colors, black or green, okay? So here it is for black. We want to see, let me write, for blacks, black color should be in the first TI that we reach 0 is what? For pink one, the first one. Then for red ones and for green ones. For each of them, try to see for which TI we will reach 0. Okay, try first on your own. Okay, for T2 we have 359 for blacks. T4 358. So if we consider sum, is it okay? So 359 will be subtracted by 1. So let me write 359 is related to T2. 358 is related to T4. 357 is related to T6. So as you can see, and we want to reach 0, and we want to see 0 is related to what? So 359, 358. So when we have -1 here, we have 2 to 4 plus 2. Okay, so when we reach 359 to 0, so we have 359 -1s. So it's 2 first one plus 2 times 359. Okay, and it will be what? It will be 2 plus. We can factor from 2. 1 plus 359, 360, 720. So in T720, we reach 0 for the first. For pink one, 1 T1, 2 T3, 3 T5, and when we want to reach 0, we should reach 360. We want to see it is T what? Again, when we have plus 1 here, we have plus 2 here. So 1 to 360 is 359. So 1 plus 2 times 359. Okay? So it will be, you can say 2 times 360 minus 1, 790. Okay. Now let's consider red ones. Okay, for red ones, 181 is in T2, 182 is in T4. Look, without also considering these things, you can see, okay, for example, green ones, 179, 178. Green ones are better because we start from 179, around 180 steps we have. But for example, black ones, we need to have around 360 steps. But I want to show you how to calculate these things. So we want to reach 360 again. Red ones and green ones are better. So here, when we have plus 1, here we have plus 2. When we want to reach 360, 360 minus 181 is 179. So 2 plus 2 times 179 is 2 times. If you factor from 2, 2 times 180, which is 360. Now for green ones. We have 179, 178 in T1, 178 in T3, 177 in T5. So we have -1, -1. We want to reach 0. Here we have +2, +2. So 179 to 0, 179 steps. And you say, okay, +1 plus 2 times 179 steps. So it will be 2 times 180 minus 1 with 359. And as you can see, green ones are when you, for example, finish T3, T5. Okay, so we will see the minimum one is this. Also, it is after applying 1 TI completely. So we don't need to check, for example, mid ones are. Can we calculate, for example, in the middle of TIs or not? Because the best answer is for green, which is at the end of each TI. So the answer is 359. Okay. Here we worked on idea 1 considering small examples. Let me tell you some homeworks that you can use the small examples to solve them. And one homework is this problem 23 of AMC 12B 2022. You can solve it with a small example. Also, you should know modula for this problem. Okay, if you want to learn 40-50 important ideas, techniques in modulas, as I said before, feel free to send message my WhatsApp number in the description. Next problem is this problem 20 of AMC 2021 Fall 12A. And you can solve this problem also with considering small examples. Next problem is problem 8 of AMC 12A 2021. So, and also in the upcoming AMCs 2023, 2024, we'll have problems that can be solved with considering small examples. Okay, if you want to learn more ideas or For the 50 important ideas and formulas in combinatorics, algebra, number theory, and geometry, feel free to send message to my WhatsApp number in the description.